Good afternoon, everybody. Have we all had a good day? Excellent, fantastic. Thank you so much for being so inviting. This is my second year at a summit in Singapore. Was anyone see me do the talk last year? A few repeat customers, fantastic. So I'm going to talk to you today about how you can use containers, Kubernetes, GKE, and Istio to solve real business problems. Now, to solve real business problems, the first thing you need is a real business. So this is Dynacorp. They make things. They don't really care so much about technology. They have a technology team. We've got about 50 people, but there's one guy who looks after the systems. He's the one systems administrator for the team. And we've got a few product managers as well. So we're going to look at Aaron and Sam and John through their workday and some of the challenges that they have and some of the opportunities that we can bring with our technology. First up, let's look at Erin. She's a developer. She wants to write code and build interesting things, but she's having a bad day. She has an application, it's running in production, and it's crashed. Who's been there? Few hands, fantastic. All right. So what happens is John, the sysadmin, calls her up and says, your application's crashed. It's not my problem. What are you going to do? So Erin says, well, it worked fine when I was deploying it on my workstation. So together, they'll look at the logs, and eventually it turns out that Erin's application needs a different version of a library than what's installed in the production environment. It's inconsistent. The wrong dependencies are in place. So now we have to do a rollback, and that's risky. Tomorrow we're going to install the right dependencies, and we hope nothing else breaks, but we don't know for sure. What we need to do is fix the root problem once and for all. So Aaron and John work together to introduce containers. We think about the growth from left to right here. On bare metal services, we package together our operating system with our hardware and our applications. We moved up a layer to virtual machines, and we have an idealized computer, a fake computer that we install an operating system on, and then we install applications on top. With containers, we move one step further forward. We create an idealized operating system, and then all the application developer needs to do is pack their code and dependencies together into a single unit. So we look at the situation that caused the application to fail. The application depends on libraries, but those libraries might not always be there or be the right version. And when the environment is more than one server, it's even worse. We can have these version drifts. So we'll fix it like so. We package the application with the libraries that it depends on, and then we deploy them onto the server. So we know that we've packed together known good versions which were tested, and we take the same artifact that we built locally or that came out of our CI environment, and that's what we run in production. There are a few other benefits of running containers. So we've talked about how they're portable and modular. But because the infrastructure is immutable, all you need to do is copy a file, start that file running. Rolling back is as easy as running the old version. And because we're running now on a kernel where we can look at and make some choices, we can make strong guarantees about sharing multiple containers running on the same machine. This is very important for Google because we used to have two sets of machines, one for running our interactive work and one for running our batch workloads. And with isolation and guarantees that containers can't use more resources than they're given, we're able to move that down to one pool. They spin up faster. You can do versioning and CI. You can treat them as pieces of code. You can easily share them, and you can look into their running state. So all these fantastic reasons to go to containers. They've helped Erin improve portability and dependency. So today's better for her. But here's our sysadmin, John. He's having a bad day too. You might remember there's only one sysadmin at this company, and we've got about 50 developers. So he's got Erin's problems 50 times over. And he struggles rolling out software. If he rolls something out, will it work? Will it work on all the machines? If it doesn't work, what does he have to do? And he wastes a lot of time and resources on these problems. So his strategy needs to change. The developers, they love containers. They've adopted them. Erin says they're fantastic. And then the next thing is they call up ThoughtWorks, and their agile coach comes in and says, microservices and continuous delivery, they're cool, you should do those. So John used to do one release every week, but now he has 50 developers who all want to release 10 times a day. So his strategy is going to have to change to accommodate these requirements. So John goes online, he finds out about the Google Cloud Summit. He comes along, and then he hears that everyone's excited about this new thing called Kubernetes. Who's used Kubernetes before? Every year, the number of hands gets more and more. That's fantastic. For those of you who are not familiar, Kubernetes is a platform to orchestrate running Kubernetes across a fleet of machines, to automate deployment, replication, scaling in and scaling out, load balancing, rolling updates, all the things you need to do to handle running your code on the many machines that make up your environment. I like to think of it as instead of flying a plane, you're programming an autopilot. You're saying, this is the state I want. I want there to be 10 replicas of this application, 30 replicas of this application, or I want this one to scale based on the number of users who are connecting to it at the time. Kubernetes' job is to make that true, is to make sure that state is always what it needs to be, even in cases of application failure, machine failure, zone failure, any of the things that can happen when you're running on computers. It's inspired by Google's tools for how we run our data centers, but instead of open sourcing that, what we thought we would do is take those patterns and say, how would we start again if we were doing it today? We don't have to write in C++ anymore. We've got this great systems programming language called Go, so we can optimize things, save people time. We can work with the community where they are. We can adopt the Docker container format, and that's where we were. It was about 4 years ago now. We've seen unprecedented community activity. It's the largest project on GitHub. We think it's the second largest project behind the Linux kernel to open source, and Google remained the top contributor. So previously, we had a whole bunch of servers, and we'd have to make decisions about what would run on each machine manually. We might have had some sort of script for rolling things out, but really we SSH into each machine and run some stuff. If it doesn't work, we log in again and check. But now we have containers. We know that we can isolate them. We can share the resources of these machines. So we're going to introduce a single control plane. And you program that control plane with a little configuration object that says, here's my container, here's some instructions about how it needs to roll out, and then it controls the nodes in the cluster. The nodes run your containers inside these little objects called a pod, and we can pack as many pods into the machine as it has to optimize the number of your pieces of work we can run in your cluster. And we can run that highly available across multiple zones. So ultimately, you just think about that. You deploy workload to the Kubernetes API server, and it handles everything else. It makes everything look like a single organism. Now, the magic of Kubernetes is when you don't even worry about the sysadmin anymore, but you build a development pipeline where you can push source code, and when the build is green, we can deploy that to our cluster, maybe to our development cluster, run a bunch of tests, and then if they all passed end to end, then we can deploy into our staging environment. So far, this has happened based on a developer pushing code. No sysadmin has been required. And then, once someone signs off, you quite often have a step where another person comes along and says, this looks good. And then we can roll that out to production, and we can do it gradually. We can do it at blue-green changeover, where we deploy a whole new set and switch over, or we can deploy immediately, depending on what our business policy is for each particular component. Again, Kubernetes solves a whole bunch of problems. Previously, we had VMs that were running at such low capacity because they needed more headroom in case you needed to scale something up. Now Kubernetes handles that across your cluster as a whole. You can get more done with the same number of machines. You can make scaling decisions not based on what you think might happen, but based on what's actually happening, because it's all API-driven and can be connected to queue lengths, to auto-scaling, to latency measurements, anything that you want. We deal with outages without intervention. We're able to do rolling upgrades, where we roll out new versions of applications steadily over time. And because this is an open source platform which can run in many different places, there's no concern about vendor lock-in anymore. Kubernetes is an API which is available on Google Cloud, but also as open source software you can run yourself, as managed services by other vendors, and in other implementations that you can have vendors support on-premise. So by delegating the release power to the developers and dealing with everything in software, now we've managed to make deployment self-service as well. Things are looking good for John. Our developers are interacting with source code. They're doing continuous integration. So now the question is, well, why does John have to deal with any of this Kubernetes stuff? Well, he has to keep the components that make up these clusters safe and secure. He needs to deploy new security patches. He needs to worry about things in the individual level. But he says, why should the developers have all the fun? They don't have to worry about this anymore. Why should I have to worry about it? So he comes along to Google Kubernetes Engine, or GKE. GKE is the representation of our decade of experience of managing containers at Google scale. What exactly is Kubernetes Engine? It's an enterprise container management service. It's a responsive, reliable, and resourceful way to manage workloads. But ultimately, it's this. You call an API, it creates the cluster for you. It runs a master, which we provide for free. It runs the nodes, which are virtual machines, which are the things that you pay for on any provider. And then you start interacting with that Kubernetes endpoint, and you don't worry anymore. You are now interacting with the open source Kubernetes the same as you run in any environment, so you have that consistency. How is GKE better? We run reliability built in with our own container operating system, which is built on Chrome OS. We have a team of security engineers who are working on that consistent Linux platform that underlies both of those environments. We have an SRE team who know how to manage clusters at Google scale, who are looking after all of this. We have an ecosystem of people who are working on tools and integrations and ways of making you more productive. And all the other things that make Google Cloud better for running VMs apply here as well in terms of cost reduction, sustained usage discounts, continuous usage discounts, and so on. Ultimately, we want you to not have to worry about running the container, not have to worry about the reliability engineering of the cluster, The managed control plane, we look after that. And optionally, if it fits your business, we can have automatic repair and upgrade for nodes. We've built them in optionally. We're actually going to default them to on in the next release because we think that that's what customers need. We will deploy new nodes as new patches are available, and then we'll move your workloads off them. The Kubernetes control plane says that node's no longer available. It reschedules it somewhere else. And then we do a rolling update of all of the nodes in your cluster. The same team who build open source Kubernetes are the people who build and run GKE. So we have the ability to create a cluster in around about 90 seconds from clicking the button on the website to having a Kubernetes endpoint that you can connect to. So that's the culmination of a decade of our work with containers. So what we think of as a container today is based on this Linux concept of a C group or a control group. And that was open sourced by Google in 2006. That was the thing that really let us start packing more workload together, more workloads onto the same machine together. And then around about 2012, we saw, well, other people have started taking these tools and making them easier to use. The Docker container format had become available at that point, and we started seeing other implementations of ideas from people who had worked at Google a little bit and said, hey, I really miss that system you have inside Google. I want to build something like that. So as we started building more cloud products rather than just releasing white papers talking about how we do these things, we said, all right, this is fantastic, but ultimately we need a product based on it. So like we said, we announced Kubernetes open source, and then soon after that, we made the Google Kubernetes Engine service generally available. We're going to show you a couple of new features, things we're working on at the moment. One of the things we've announced this year is that we're going to be working with customers where they are and bringing GKE to run in their on-premise environments, which I'll talk about soon. A couple of cool new features in GKE that you won't find anywhere else. First of all, private clusters, being able to run a managed cluster without needing a public endpoint, being able to have secure internal communication between users and nodes. You can't be connected to by default from outside the cluster, but you can enable them so that you can for certain IP addresses for management reasons if you want to. We've recently launched regional clusters to generally available. So we have multiple masters behind the scenes, spanning the different zones within a region, replicating the control plane, and then you decide how you want to replicate your nodes. So that in the event of a complete zone outage, as rare as they are, you can still have two other zones running your work. And again, the control plane will say, if that work is not running because it has no longer got the 100 pods you asked for deployed, it will deploy more in the zones that remain. Another great thing that Google offers, which no other vendor has, is regional persistent disks, which is the ability to write to a disk in one zone and have those changes replicated behind the scenes to a second zone. So if the zone fails, in previous times you would have to look at the last time you took a snapshot. You would have to restore that snapshot to a different zone, and you would have to hope that you could get your database consistent again. Now, you define all this in Kubernetes. If that zone goes away, the secondary zone simply becomes the master from that disk. The writes are there because they've been replicated before they were acknowledged back to the application, and your application keeps running. So it was easy to run stateless workloads in a highly available multi-cluster, multi-zone setup. Now it's easy to run stateful workloads. We've recently added support for a few cool Google networking features. So we have our Cloud Content Delivery Network, CDN. We have an identity-aware proxy so that you can say only people who have certain Google accounts are able to access applications. And we have a web application firewall called Cloud Armor. And all of these can be configured in your Kubernetes environment. You say, this is how I want to configure my load balancer to connect into my network, and it configures the load balancer for you. You don't have to worry about doing that manually. If you're running a cluster multi-region, so if you want to be able to run, for example, some of your nodes in Singapore on one cluster, and some of your nodes in the US or in Europe on other clusters, we recommend that you don't run a single cluster with nodes in multiple locations, because for replication reasons, you don't want certain nodes to be closer to each other or lower latency than others, but run them in different clusters. And then, because we have a globally available load balancer, you can use multi-cluster ingress, which is a way of configuring that load balancer to be able to talk to backend services that run in both of those environments. Stackdriver Kubernetes Monitoring is another thing we've recently announced, which is a full monitoring suite for Kubernetes environments. You can have dashboards that let you drill down for various different views. So you can drill into the infrastructure view and saying, what are my particular nodes running? Or you can look at my workloads and say, regardless of where they're running, show me the state of these things. You can see the red lines across the top show times where there were problems with our application, so we can easily go back and look at our timeline. And it ingests metrics in the common open source Prometheus format, which are exposed by Kubernetes itself, by a lot of common applications, and there are libraries that let you build into your own applications to very easily describe the state of your application in a way that our monitoring software can pick up. Now, we've seen a lot of people implementing serverless frameworks and doing that on top of Kubernetes. We've had App Engine for 10 years now, which is basically the thing that pioneered the serverless idea, the platform as a service. So we've taken our experience running App Engine and what we've learned from running containers in GKE, and we've built serverless into GKE with the GKE serverless add-on. We have components that handle building containers, that handle serving, dealing with versions as they're deployed, and responding to events, whether it be web traffic or whether it be changes to files uploaded in a bucket or events in a pub sub queue. And we took all that and we've open sourced that as well. So we have a new open source platform called Knative. It's a set of modern components for building all of these things where you don't want to have to worry about the boring but difficult parts in your serverless implementation. The same as Kubernetes provides this API that everyone can use, we're seeing serverless platforms adopt Knative. And we're excited to see what comes up in this space. So the bottom line is we keep innovating with serverless, and you can get that benefit knowing that there's no worry about lock-in. You can define your serverless applications with an open source API the same way that you did with Kubernetes, and many vendors will have an implementation who are able to respond to that. Now, our customers have been saying GKE is fantastic, but there's still a few things we have to run on-premise. Can you help us with this? So yes, in July at Google Cloud Next in San Francisco, we announced GKE on-prem, which is the Google Kubernetes experience running in your data center. It's the same consistent experience that you get running on cloud and on premises, tested and validated by Google. And we have a single pane of glass which lets you look at the state of all of the clusters no matter where they're running, as you see here. It runs the same open source pieces as any other Kubernetes version, has the same add-ons and configuration as GKE. And we can do this because we know how Google built Kubernetes and how best to run it. So we're going to be able to run it in your environment as well. We are excited. We've had a large number of people interested in this, and I've obviously had a number of you today come up and talk to me about it. So there is a form you can fill in online to get access to this. We are very slowly going to be taking people off that form over the next few months because we had so much interest. But if you are interested, do get in touch, and we'll talk more about that. Here's a quote from one of our customers about GKE. Since we moved to Google Kubernetes Engine on Google Cloud Platform, our development is much easier. There is no extra work for our team in having to manage our extensive environment, allowing us to ship faster and focus on more strategic projects. So again, we've made John's life better. He's managed to improve his utilization, do more with fewer machines, save money. He's been able to de-risk his deployments, ultimately saving money as well. So he's got so much more. Let's have a look now at one of our product managers. This is Sam, and well, things are going all right for Sam, really. He's really excited about the possibilities for his new microservices architecture and his deployments. And he wants to get his software out to users as quickly but as safely as possible. And he wants to do canary deployments. He wants to test the features with a small percentage of his users. So we're going to deploy a new version of an application. We might want to test that with just a small percentage of our audience, or it might be targeting a very particular subset of our audience. So we might be doing a bug fix for iPhone users who are running Firefox, or Android users who are running a particular tablet screen size, for example. And once we've tested that that feature branch does what it wants, we want to scale that out to everybody. So Sam looks at the ways that he can solve this problem, and he goes to John and says, I've heard about this cool new tool called Istio. What exactly is Istio? It is a platform for configuring, securing, managing microservices. Like Kubernetes, it's an open source project pioneered by Google. We've worked with IBM and with Lyft. It's inspired by Google's tools for managing APIs internally. Built for Kubernetes first, but not only Kubernetes. This extends to many more environments. And it's this thing which in the industry we're starting now to call a service mesh, or a smart network, where we don't need to build the smarts into our applications, but we instead make the network smarter. How do we do that exactly? Here is a sample architecture that we might have. We have users who access a front-end service, and it needs to call a bunch of other microservices, some of which are running in the Kubernetes cluster, some of which are external on cloud, some are external and not on cloud. When we install Istio, alongside your code, the container provided there, we add a second container into the pod, and we run them together. And this is the engine, the data plane for Istio, is a proxy, open source software called Envoy, which gets deployed alongside your container and then programmed by a control plane in the same kind of way that you think of the nodes have the Kubernetes agent and are programmed by the Kubernetes master. So we end up with an architecture that looks like this, where every application has the proxy server deployed alongside it. And that lets us do a bunch of cool stuff. So we are now intercepting all of the traffic between the services in our environment. We can check for every call that is made, we can check policy and see if this should be allowed or not. It can be, is it allowed ever? Is it allowed now? Have we exceeded a rate limit or a quota of some sort? We can look at the state of the environments that we have, and we can tell whether or not particular services are running or have higher latency. Or we can say, if a request doesn't return within a particular time, instead of waiting longer, just do a circuit break and return an error page that says that's not available right now, and fail a certain portion of our application while making it better overall. Our control plane there has also a point where we can get telemetry information. So we record when calls start and end at those proxy servers, and we send it to our Mixer service, which has plugins that let you export metrics and logs to services like Prometheus or Grafana or Stackdriver, which allow you to look at latencies of calls inside your environment. Previously, you might only have been able to do that from users to the outside. Let's have a look at what Sam can do for his testing. In the past, canary testing was tied to infrastructure. So if we had users connecting to a service, we might say, well, I only want 10% of my users to connect to version 2. And there was a way to do that, but it's not very good. We'd do this. We'd deploy 10 times the number of servers that we need, and then any one of them gets 10% of the traffic. Say, well, that's great, but it's kind of a random allocation, and it's very wasteful. What should we do? Because with Istio, the traffic flow is completely separated from the underlying infrastructure, the number of pods there doesn't matter, we can just configure the gateway to say 10% of my traffic goes to this version, 90% goes to the rest. And we only need one container for each if that's all we need to be able to serve those requests. Because that proxy server is intercepting the traffic at the application layer, we can look at things like HTTP headers that we couldn't previously look at in network routing decisions. So here's an example of how you might achieve that using Istio. We have here a route rule which says 90% of our traffic should go to the version 1 subset, which we define by using Kubernetes labels. And then 10% will go to version 2 alpha. So traffic there generated by our front end, the proxy will decide 90% of the sessions, and again, that isn't just by number of packets, but by user sessions, 90% goes to this service, and then 10% goes to the other one. If, for example, we wanted to steer traffic using HTTP services, we can look at the user agent, looking there with a regular expression to say, users that are running on an iPhone get routed to this particular service, and users that are not get routed to the other one. We can test various features for various deployments. And again, we couldn't do that with layer 3 because we were just seeing packets. We had no idea what the actual device was previously. So now we've moved from these monolithic applications and broken everything down to microservices. It's very hard for John to tell the state of the applications in his environment. It used to be simple to debug an application. You could look at the traffic flow just within that binary. But now it's complex because these are different services that could be running on completely different machines. So with Istio, you can get descriptions of what's failing through that monitoring integration. And you can also do distributed tracing. You can see a call and all of the microservices that it passes through linked together into a trace. And you can tell, for example, when services are taking longer to respond than they should and under what conditions. And we see a lot of people here, like Carl from AutoTrader, who are finding problems in their application that they didn't even know that they had under certain conditions, because they're able to see that from looking at things like 99th percentile latency and distributed traces. Running Istio, even before it was running 1.0, a number of customers running it say that it has helped them surface issues that they didn't know that they had. Now, I have a little bit of bad news. This is the CFO. Her name is Martina, and she's just come back from a board meeting, and she said, no, I've heard that traffic isn't all encrypted. I demand the board say every traffic must now be encrypted because reasons. So she wants to be able to say that to please her regulators. The situation with our environment is this, is that today anyone can call that front-end service, and it'll make a request to the payment service. Nothing's verified with this, though, because that could be provided to an attacker who's got into your environment and is pretending to be the payment service. And then that service could send the information out to an exfiltration endpoint rather than the bank itself. So even when our endpoints are trusted, the communication's in the clear, and someone who got onto one of your machines might be able to intercept that traffic. So ultimately, we want two things. We want to be able to know that every endpoint is who they say that they are, which is authentication. And we want to be able to encrypt all the traffic on the network. Now, because, as I say before, we are intercepting all this traffic, we can do that. And we can do it without changing anything in our applications. We have a service called the Citadel, which runs in the Istio control plane. It issues identities and certificates to each service as they're deployed to the cluster. It rotates their credentials as they need to be rotated. So now the front-end service there will only connect to a service that is claiming to be the payment service if it has a signed certificate claiming that it's correct, and vice versa, and the front-end certificate is signed. And then the traffic between those two services will be encrypted. And those identities are then passed up to your application. So if you want, you can make policy decisions like only the payment service is allowed to talk to the banking service. If the front-end service tries to talk to it, it shouldn't be allowed to. All of this is implemented without you having to make any changes in your application. So a few other things that Istio can do. We talked about traffic control, and we talked a little bit a little bit about observability and security. Fault injection is a cool thing. We can say, what does it look like if we have poor network conditions? If things aren't working quite the way that we want, we can simulate that. We can say, what if call A to call B lasts longer than it should? How is that for my end-to-end? If I have several microservices in a chain, it might be that we don't know how long injecting latency is here. And ultimately, if you're building up a web page from lots of different services, it might be that you'd rather that the thing loads but doesn't have some functionality rather than waits forever for something it doesn't necessarily need. Hybrid cloud is another cool thing. If you haven't yet, I'd encourage you to go and look at our multi-cluster demo at the Kubernetes booth later on. We have a mesh now extended to 2 different clusters. We have one running on GKE on cloud, one running GKE on-prem. And we are able to do service discovery and make calls between these clusters. Just calling, say, call the host name payments, and that service could be running in a completely different cluster, but we're able to mesh these 2 things together. So Sam has used Istio to easily manage his Canary deployments, and he's gained a whole lot more out of it too. Kubernetes empowered developers to take care of deployments. Istio moves up the stack to solve problems that we will invariably encounter when we're deploying microservices. And GKE is the best place to run Kubernetes and Istio. If you've enjoyed listening to me talk for the last half an hour, the best place to keep up with Kubernetes is on the weekly Kubernetes podcast from Google, which I host with my colleague Adam. Search for it in your podcast player or go to kubernetespodcast.com. It's a 20-minute show with an interview, news of the week. I'd love to hear what you think. If you're interested in getting started, here are a few pages on our cloud website telling you about the things we talked about today, about containers, about Kubernetes engine, GKE, and about Istio. Just leave that for people taking photos for a second. And with that, it just leaves me to say thank you very much.